Okay, welcome back to Mr. Hassan's Maths channel. I'm now going to answer number 10 from the Pure Mathematics P4 January 2021 International A-Level Edexcel paper, and this is the last question on this particular paper. Part A, it says write 1 over h minus 5 times h plus 3 in partial fraction form. So we've got to take this fraction, which is expressed as one fraction, and express it as separate fractions. We must split it apart, put it into parts. So the way to do that is set up an identity where you see you have 1 over, and you've got h minus 5, which is a linear factor, times h plus 3, which is another linear factor. So I can see that this is a proper fraction because the numerator, if h is a variable, the numerator is of the form of an order which is less than the denominator. The numerator is in the form of a constant. The denominator is quadratic, so it's a proper fraction. So I won't have a whole number part. It's just going to split up into something divided by h minus 5 plus something divided by h plus 3. So I'll call those somethings a plus b. Now this is identity. This is an identity. They're both identical to each other. Now I want to now get rid of the fraction. So what I'm going to do is I'm going to multiply both sides of this identity by the LCM of the denominators, which is h minus 5 times h plus 3. So here, if I multiply this side by h minus 5 times h plus 3, I end up with 1 because they cancel out. If I multiply this term by h minus 5 times h plus 3, well, the plus 3 part cancels out. Sorry, the h minus 5 part cancels out. We're left with a times h plus 3. And if I multiply this term by h minus 5 times h plus 3, the h plus 3 part cancels out, and you're left with b times h minus 5. So it's always this over that one, and that over that, this times that one, and this one times that one, multiplied by the other one. Now we can use different techniques to find a and b. Probably in this case the easiest technique is if I substitute, for example, h equals 5 into this whole identity, then this will become 0, and I'll be left with 1 is equal to a times 5 plus 3, which is 8. So therefore I can say a is equal to 1 over 8. And if I put h equals, for example, negative 3, then this term will disappear and I'll be left with something here. So I have 1 equals b times minus 3 minus 5, which is minus 8. So therefore we can say b is equal to negative 1 over 8. So now we have found the value of a and b. We can now express this. So we can say 1 over h minus 5 times h plus 3 is equal to, and we can express it as 1 over 8 times h minus 5 minus 1 over 8 times h plus 3. And there's the answer to question 10 part A. Okay, now on to part B. Okay, now for part B. I've just brought the result over from part A because we most probably might need this in this section. Normally that's what happens. Part A and part B are related, so I've just put the result here in case we need it. Now it says the depth of water in a storage tank is being monitored. The depth of water in the tank, h meters, is modeled by the differential equation dh dt equals minus h minus 5 times h plus 3 over 40. Okay, so the rate of water, the rate of change of the water in the tank is given by this equation. So it's the rate of the water in the tank is basically it's falling, it's minus, and is given by this particular equation, right? Where t is the time in days from when the monitoring began. Given that the initial depth of water in the tank was 13 meters, solve the differential equation to show that h equals this particular equation. So we've got to solve this differential equation, meaning we've got to express h in terms of t. Okay, as we can see here. Okay, when you solve it, you've got to express what's on top here in terms of what's underneath here. So without the differential, so without the rate of change, you've got to basically change this into h equals some function of t. That's what it means. Okay, so if you're solving a differential equation, you're basically changing the dh dt into h equals some function of t. That's what we're doing. Okay, that's how we have to have it in the end. Okay, so now In order to solve this differential equation, we're going to start off with what they had given us, which is dh dt equals. So we have dh dt is equal to, I'm going to leave a bit of space here because of a particular reason which I'll explain, equals to minus, and you've got h minus 5 times h plus 3 divided by 40. Okay, now when you're solving a differential equation, what you're actually doing is you're doing the same thing to both sides. So for example, when you have dy dx equals something, for example, supposing you start off with dy dx equals, let's say start off with dy dx equals x squared plus 2, and you want to find what y is. What we normally do is we say y equals, and you've got to basically integrate this. So you say y equals x squared plus 2 with respect to x. But where does this come from? Okay, I'm just going to explain just a little bit of where it comes from, just so that we understand the basis of these differential equations. What you're actually really doing is you're saying, let's integrate this side with respect to x. Therefore, we must integrate the other side also with respect to x. So you end up with the integral of 1 times dy equals the integral of x squared plus 2 dx. And when you integrate 1 with respect to y, you're going to get y. And then you integrate this side with respect to x, you get x cubed over 3 plus 2x plus c, and so on. So basically that's a step that we normally don't think about. We go straight from here to here. We don't think about these two steps. But that's really in reality what we're actually doing without actually writing it down. We don't think about it in this way normally. So okay, dy dx, how do I get from dy dx to y? I have to integrate integrate this side, and it's going to become y. What you're actually doing is, as we do in all equations, when we're solving equations, we do the same thing to both sides. So what I'm actually doing is I'm integrating this side with respect to x, and I'm also integrating this side also with respect to x. Okay, so then you end up with these dx's cancelling, and you end up with the integral of something, basically 1 times dy, 1 dy, and the integral of x squared plus 2 dx, and then the integral of 1 with respect to y is y. That's where the y comes from, and then you integrate that side with respect to x. So of course you don't have to write that down, and I wouldn't advise you to do that in a normal type of integration question. I just want you to understand where these steps come from. Okay, some people just memorize things like you move this there and you move that there and you put this there and you put that there. But I want you to understand what's actually happening here is we're integrating both sides with respect to t. That's what we're going to do. So I'm going to integrate this side also with respect to t. Okay, that's what I'm doing. Now this cancels with that, and you're left with the integral of dh on this side equals, I'll put the minus outside, and I'll put the integral of, you're going to have h minus 5 times h plus 3 over 40 dt. Okay, so now this side has basically 1 times the integral of, you're integrating this side with respect to h and this side with respect to t. So any h terms must end up on this side where it says dh, and any t terms must end up on the side where it says dt. Okay, that's how you have to separate, what's called separating the variables. So what I'm going to do is I'm going to divide both sides by h minus 3 and h minus 5 times h plus 3. So on this side I'm going to have 1 over, I'm going to have h minus 5 times h plus 3. I'm also going to multiply both sides by 40 just to get rid of that 40 there. Okay, so you end up with without a fraction on that side. So that side is going to be integrated with respect to h equals, and I'm going to have basically minus 1 dt. That's what I'm left with here. Okay, so I'm setting up my integration now. Okay, now another little trick to save me from writing plus c when I'm doing my integration. It's a very nice little neat trick which will really make life easier for you, is using this thing that they told us, that the initial depth of the water in the tank was 13 meters. Initial depth means when time is equal to 0. Okay, initial depth is when time equals 0. Big H is equal to 13 meters. Okay, so I can now use that here, that I want to find h in terms of t. So I'm going to put h there and t there. I know when t was 0, h was 13. So putting the limits like that in here is going to help me to find the equation without having to worry about plus c. It will automatically find the plus c for us because we have these limits put in there. All right, the value of c will be found automatically using this technique. Okay, so now we have to integrate these. Now this is where part A comes into play, because to integrate this section here, this part here, we have to split this into partial fractions, which we've already done, okay, in part A. So that's already up here, so I'll just bring that down for us to see over here. Okay, that's how we split it into partial fractions in part A. So I'll just write this over here so we can see what we're doing. So this is going to be 40 times, 40 times the integral between h and 13 of, and we're going to have 1 over 8 is like common factor, so I can take that 8 out here. That will make life a bit easier, okay, because you can see that 1 over 8 is common. So I'll write 40 over 8. That leaves me with 1 over h minus 5 minus 1 over h plus 3. And that has to be integrated with respect to h, and that's equal to the integral of, well, minus the integral of t of 1 with respect to t between t and 0. Okay, now integrating this, this is going to be a 5 outside here. Now I can integrate this. I have here the integral of 1 over h minus 5 gives us the ln of the modulus of h minus 5 minus, and this is the ln of the modulus of h plus 3. Now I have the limits of h and 13, and that's equal to the integral of, well, minus the integral of, sorry, integral of 1 is t. You'll end up with t in here, and you got a t and a 0. Okay, so now what does this give us? Let's keep the 5 outside first. So you have 5 times, and this will be, as it is, ln of h minus 5 modulus minus, in fact I can actually make it a bit simpler first by using division. I can say this is 5 times, this is the ln of the modulus of h minus 5 divided by h plus 3 between the limits of h and 13. On this side I can say this is going to be minus t basically, and minus t minus 0. Now I can put my values of h and 13 in here. So I'm going to have, I think I need space on the next page. Let me just continue for a little bit here. I'll have 5 times, and this is the ln of h minus 5 over h plus 3 minus the ln of, now I'm going to put 13 in here. So that's going to be 13 minus 5 is 8 over, and 13 plus 3 is 16. Okay, and equals negative t. Now over here you see we didn't have to put plus c because we got definite integrals, and that was the reason why I wanted to put the limits in the beginning, so I don't have to mess around with the plus c and find what c is. This is going to automatically give us something that we can use. But let me just try to, I'll need some space on the other side, so just let me get that. Okay, so here we are. Now that's how we have to express the answer in the end. That's how it's supposed to come out, and that's where we've got so far. So I see I have a minus 0.2t, and if I divide both by 5, both sides by 5, I'll have minus 0.2. I'll have minus 0.2t. That might help us. So also what I can do is at the same time, this is going to be ln of a half. So I have the ln of h minus 5 over the ln of h plus 3 modulus minus the ln of a half. Okay, I don't have to put that modular sign because it's positive, is equal to minus 0.2t. Okay, that's going to kind of help us, hopefully. Now, to make this a bit simpler, this is like plus ln 2. Minus ln a half is the same as plus ln 2, because it's 2 to the power minus 1. The power law, that becomes plus 1, and you have ln 2. So I can rewrite this actually as ln 2. Okay, so I'll do a separate step. So I'm going to have ln, I'm just trying to make it a bit easier for me to deal with, that's all. H plus 3 plus ln 2 equals negative 0.2t. I can combine these two together now because I want to make them as one ln. I don't even need these brackets actually anymore. Okay, because that's going to be the ln of 2 times h minus 5 over h plus 3. Okay, and that's equal to minus 0.2t. Now I can get rid of the ln. I can rewrite this in terms of logarithms. I know this means log to the base e of all of this equals minus 0.2t. So we know log to the base ab equals c can be rewritten as a to the power of c equals b. The base, the power, and the answer. So the base here is e. So this can be written as e to the power of minus 0.2t is equal to all of this, which is 2 times h minus 5 over h plus 3. So now we can rearrange this to make it into this form. So let me just bring this down here so we can see exactly how we're supposed to write it in the end. We have to manipulate it so it becomes exactly like this. So let's go ahead and carry on with that. I can get rid of the fraction first because I want to have one h term. I see I have 2 h terms. So I'm going to expand the brackets, get rid of the fraction, bring the h's on one side. So this is going to be h times e to the power of minus 0.2t plus 3 e to the power of minus 0.2t. Okay, equals, and this is going to be 2 times h minus 10. Okay, now I can see here that I'm almost there. I've got 10 plus, so if I bring the h's on this side, I'll have 2h minus h e to the power of minus 0.2t. On this side, we're going to have 10 plus 3 e to the power of minus 0.2t. So I've got that there, and now I can see now how I'm going to get it. Take h as a common factor here. You have 2 minus e to the power of minus 0.2t. On this side, you've got 10 plus 3 e to the power of minus 0.2t. And now the next line, we've done it. Basically, we can divide both sides by this. So we're left with h equals 10 plus 3e to the power of minus 0.2t divided by 2 minus e to the power of minus 0.2t. And we have shown the answer very clearly. And that's the answer to part, I think that was part B. Okay, so we got this answer here for part B. And now for part C. Okay, so for part C, it says, hence find the time taken for the depth of the water in the tank to fall to 8 meters. So this is the equation that we've found, that we had to show. So this is the equation that we have to use. Now, let's just go back and think about what the actual question was about. It says the depth of water in the tank, h meters, is modeled by this equation, where t is the time in days from when monitoring began. Okay, so basically, h is the depth of the water in the tank. So we want to find the time taken for the depth of water in the tank to fall to 8 meters. So h has to equal 8 meters. From 13 to 8. Remember, 13 was the maximum, I think, height. So the height is, the 13 was the time when time was 0. That was right. So when time was 0, it was this. So we know when time was 0, we know that h was 13 meters. And we want to find what time, how many days it will be for it to fall to 8 meters. Okay, so basically we have to just substitute 8 into here and find and solve for t. Okay, so we have to say 8 equals 10 plus 3 times e to the power of 0 minus 0.2t over 2 minus e to the power of minus 0.2t. So I have to make this e to the power of minus 0.2t the subject. So I'm going to multiply both sides by this first to get rid of the fraction. That's going to be 16 minus 8 e to the power of minus 0.2t is equal to 10 plus 3 e to the power of minus 0.2t. I'll bring the e's on this side. So this is 3 to the power of e, 3 times e to the power of minus 0.2t plus 8 times e to the power of minus 0.2t. Okay, and this side is going to be 16 minus 10, which is going to be 6. All right, so I can subtract these two. That's going to give me, add these two, sorry. That's going to be 11 e to the power of minus 0.2t equals 6. I can divide both sides by 11. So I have 6 over 11 equals e to the power of minus 0.2t. Now what I like to do myself, I like to if this is like a negative power, I like to write it as its reciprocal, which is e to the power of 0.2t. So if it's equal to 6 over 11, if this is equal to 6 over 11, then the reciprocal will be equal to 11 over 6. And now, remember, we can take we can basically take the log to the base of 0. We want to get rid of the we want to get rid of the e, so we can take the ln of both sides. Sorry, we can take the log to the base e of both sides to get rid of the e. So if I take the ln of both sides, I have I'm just going to continue over here. I'll have the ln of 11 over 6 is equal to 0.2t. So I can say t is equal to, this is 1/5, so it's 5 times the ln of 11 over 6. Now, they probably want it in days instead of exact form. So let me get the calculator and sort that out. Okay, so we got 5 times the ln of 11 over 6. That gives us 3.03. So 3.03 days to 3SF. Okay, they didn't say how to round it. No, so we'll just put 3.03 rounded to 3SF. Okay, if they said in terms of days and hours and minutes or something, no, it just says the time taken, and we know that it's in days, so we just write 3.03 days. Then it says, according to this model, the depth of the water in the tank will eventually fall to k meters. State the value of the constant k. Now, some students have a problem with this question. Okay, I'm going to explain to you how exactly to do it. It's only worth 1 mark, so you don't actually have to show any steps, really, although it's better to, because it says state the value of it. I know the answer is going to be 5, and I'll explain why eventually, but let's just get the calculator and show you why, or show you how, more like. So let's take this, and I'm just going to substitute. I'm going to write this exactly as it is. 10 plus 3 times e to the power of, which is this button over here. I'll put minus 0.2, exactly as it is, but I'm going to put t as a really big number. 0.2 times, I'll put t as a really huge number, like let's put like times 1,000,000. Right, just say put it as a really big number. All right, so I'll put that in the brackets and over here. Okay, so I made t really huge. So eventually, so when t gets really big, it's going to fall to it's going to reach a certain amount. So let's put t as something really big and see. So here we got 2 minus, I'll have e to the power of minus 0.2 times, again, I'll put a really big number like 1,000,000. 1, 2, 3, 4, 5, 6. Again, let me just put it into the brackets to make sure. Okay, now this answer should come out as 5, and it does, you see. So I know that the answer here is h equals 5. Okay, now I'll explain why now as well. I don't want you to just, that's how you can work it out in an exam, very simply, just putting a really huge number instead of t, and you'll see that's what it will come out as. But I'll explain to you why now. This is like h equals 10 plus 3 over e to the power of 0.2t divided by 2 minus 1 over e to the power of 0.2t. Now, as t gets really big, then we can say 3 over e to the power of 0.2 times infinity, something really big, is going to go towards 0, because you got 3 divided by a really big number. E to the power of something really big is going to be basically something really huge. 3 divided by something really huge basically goes towards 0. And the same with 1 over e to the power of 0.2 to the power of infinity, that also goes towards 0. Okay, because it'll be 1 over infinity. So that means you're going to end up with h equals, so you can say as t approaches infinity, h approaches 10 over 2, which is equal to 5. Okay, so the constant k is going to equal 5. So I'll put k equals 5 here. Okay, k equals 5. That is the value of h that the height will eventually fall to. Okay. Okay, so that's how you answer part D, and I think that's it. That was the last part of the question, and that was the last question on the paper. So that completes P4 of January 2021 International A-Level Edexcel. Other questions from this paper can be found on the playlist that should appear somewhere in this region here. Other questions from this topic of differential equations, which is under integration, I guess, will be in this playlist over here. You can subscribe to my channel by clicking on this link, and on the top of the page you will find a link that takes you to a different P4 paper you might want to see. Thank you for watching, and see you soon.